Alright, Calc 3 class, let's do an example of a line integral when we have a potential function. So we're being told to confirm that this is a potential function. So first, how would we do that? We would need to take find the gradient of v and show that the gradient of v is f, is how we would confirm that. So these are the partial derivatives for x, y, and z of the scalar function v. So you can see that this is equivalent to our force field. So this is a potential function for this, all right? And our force field is a gradient field. All right, and then it says determine the length of the line integral along this curve. So pi over 2 times t minus 1, pi over 9 times t from 0 to 1. Okay, remember, this is how we're getting our x, our y, and our z. This is our x function, our y function, our z function. And we plug in 0 into this, we plug in 1 into this, and that will be our 2 points that we can just plug into this original equation. All right, and then what's the line integral? Again, if we did our notation, our integral of c of f dot dr, all we have to do here is plug in these three at the ending point. So we're going from 0 to 1. So these three into the original minus plugging in these three into the original. So I'm going to plug 0 in for x into this. All right, the cosine of 0 is 1. I'm going to plug in pi over 9 in for y. All right, so that's going to be pi over 9 right there, and then the z is going to be 1. So 7 times pi over 9 is 7 pi over 9 times 1 is 7 pi over 9. Cosine of 0 is 1. So this part is 7 pi over 9. Okay, and then we are subtracting what happens when we plug in negative pi over 2 in for x. And notice that's going to be the cosine of negative pi over 2. Well, that's going to be 0. And then the other two are 0 as well. So no matter what, when we multiply all this together, we're going to get minus 0. So our answer is just going to be 7 pi over 9. All right, so there's our answer. Let's plug it in to the Hawk software just to confirm. All right, and we will submit our 7 pi over 9 answer, and that's what we got, okay? So when we have a potential function, when we have a conservative vector field, whether it be 2D or 3D, the examples I gave in the previous video were 2D, but it works for 3D as well. If it's conservative, meaning there is a gradient, it's a gradient field that we're working in, there is a potential function that the gradient comes from, all we have to do is find the x, y, and z coordinates at the limits of our integration, our lowest point, our highest point, subtract. That's the fundamental theorem of line integrals.